Hello and welcome back. Today let's look at this problem. Find the slope of the line r equals 4 plus 6 sine 2 theta at theta equals pi over 6. Well, how are we going to find the slope of the line? We know that slope is equal to dy over dx. But how are we going to find dy and dx when we're looking at a polar function like this one? Well, recall that y in polar is equal to r sine theta. And we can see that basically this y equals r sine theta, this r over here, this is your ray. And then if we draw a line down here across, this is going to be your y value. Well, why is that equal to r sine theta? The answer is because sine theta is equal to opposite over hypotenuse. And if you look at sine theta, blah, 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 you're gonna bring this hypotenuse across. You're gonna get hypotenuse times sine theta equals opposite. And now you can see over here, if this is our theta, then y is easily going to be the opposite, and r is going to be the hypotenuse. Therefore, you're going to get r sine theta equals y. The same thing goes for x. This is your x over here. Now, cosine theta equals adjacent over hypotenuse, where the adjacent is going to be your x, because this is your adjacent angle, your adjacent side right here, and then that's over your hypotenuse, which is going to be r. Now, if you cross multiply, you get r cosine theta equals x. Now, let's just write that over here because we can see it better. X equals r cosine theta. Now, how are we going to find dy? How are we going to find dx? First, we can look at dy dx and say, hey, this is equal to dy d theta over dx d theta. Now, we can easily find dy d theta and dx d theta. We just have to remember something very important, which is the product rule. So, if we're finding dy d theta, we go over here, we see this r and the sine theta. Those are two different terms, so we're going to need to use the product rule since it is the product of r and sine theta. So we get r prime sine theta plus r times cosine theta. Remember, right? For instance, ddx a b equals a prime b plus b prime a, right? Okay. Then dx d theta will be equal to r prime cosine theta plus r times negative sine theta, because derivative of cosine is negative sine. So overall, we're going to get, see if I have enough room here, dy dx equals r prime sine theta plus r cos theta over r prime cos theta minus r sine theta. Now, let's get rid of some of this stuff over here. I think it's pretty useless now. All right, so back to it. Now, if we're going to try and find dy dx at pi over 6, let me get back to my marker, pi over 6, we're going to need to plug in pi over 6, theta equals pi over 6, into this equation down here, right? Now, in order to do that, first we need to find r. Well, r is equal to 4 plus 6 sine 2 theta. Now, if you look at this, we can easily see that 2 times pi over 6 equals pi over 3. And we know that sine of pi over 3 is equal to rad 3 over 2. Not the nicest numbers, but we'll make it work. And then, so r will just be equal to 4 plus 6 times rad 3 over 2 equals 4 plus 3 rad 3. Now, let's just plug that in. dy dx equals, and first we should remember, we should just make a little table over here. Sine pi over 6, because we're going to need to plug these into our equation down here. So it'll be useful to have these values for us. Sine pi over 6 equals 1/2. Cosine pi over 6 equals rad 3 over 2. Okay, now dy dx equals, and then we just plug in this r prime here. Oh, we should also do that. R prime is going to be equal to, well, we kill this 4 down here. We don't need that 4 because it's a constant, it dies. So dr d theta is going to be 2 theta. Okay, we're going to use a chain rule there. It's going to become 12 times cosine 2 theta. And now 12 cosine 2 theta is 12 cosine 2 times pi over 6 is 12 times 1/2 is 6. So r prime equals 6. Now, let's just plug all that in. So we get 6, and then sine of theta is going to be 1/2 plus r times cosine theta is 4 plus 3 rad 3 times cosine theta is rad 3 over 2, and that's all divided by 6 times cosine theta, which is rad 3 over 2, minus r sine theta, and r is, again, 4 plus 3 rad 3, and then sine theta is 1, well, is it 1/2? It is 1/2. All right, sine theta is 1/2. And then we just circle our answer because this is in calculable form. And you know what? On the AP, calculable form is okay, and I do not feel like evaluating this. So that is how you solve for the slope of a line in Polar. Thank you for watching. See you next time.